Hi, my name is MG Blue Blake G Cubos. You can call me MG.
And hi, my name is Mathieu Cas, but you can call me Matt or Matthew. And with that, let's get right into the lesson. Now, with us, let us all learn the significance of this so-called Pascal's triangle. Before we proceed, let us first talk about the overview of what we are about to discuss today. We have the question, what is Pascal's triangle? Who do you think invented Pascal's triangle? Then we have the different uses of Pascal's triangle and some of a few examples.
Now, what we have here is a general introduction of what Pascal's triangle is all about. What is Pascal's triangle? It is a number pattern that arranges numbers with coefficients, the expansion of any binomial expression. It is a method used to know the binomial coefficients of terms of a binomial expression, x plus y raised to n, where n can be any positive integer and x, y are real numbers. Beginning with 1 on top and with 1 running down on the two sides of the triangle, in which each new number between two numbers and below them and its value is the sum of two numbers above.
Now what is shown on the screen is a Pascal's triangle that is up to the power of 12. Let us now talk about our curiosity. Who invented this Pascal's triangle? Well, from the name itself, this man is none other than Blaise Pascal. Named after a French mathematician and philosopher, Blaise Pascal, who was born in 1623, was the first to write an organized work about his treatise. The treatise on the arithmetical triangle, known today as Pascal's triangle. Beyond his work, he made a huge contribution in the field of mathematics, as this triangular expansion contains numerous patterns that help in computing and solving complex calculations much easier and faster, in which humankind can use to further progress in a world full of equations. Here is a famous quote that we would like to share to you that was said by Blaise Pascal. The virtue of a man ought to be measured not by his extraordinary exertions, but by his everyday conduct.
Now, when we apply Pascal's triangle, there are different ways where we can use this. For example, in statistics, in algebra, probability, in theories, even combinations, and of course, binomial theorem.
Now here are some examples regarding Pascal's triangle. We have example number 1. Let's take this equation, x plus 2y cubed, or to the third power. Now using the Pascal's triangle, this is what we're gonna have. So 1, 1. Here we have 1, 2, 1. And here we have 1, 3, 3, and 1. Which is what we're gonna use in this equation here, since it's to the third power. Let me just erase this real quick. There we go. And now, let me just write this down so that we'll have the guide. And let's write it down. 1 plus 3 plus 3 again, then plus 1. There. And now, let's write the given. X cubed, because you get the cube. Then we have x squared times 2y 1. So you still get the sum of 2 and 1 to 3. And here we have x1 times 2y to the squared. So still just reverse it. Then we have just the 2y cubed. We have our expanded equation. And our first term will be x cubed. Then here we can just multiply the regular numbers, bring down plus first, then this will become 6x squared y. And then that's our second term. Then here we have x squared, which is 4 times 3, equals to 12. Then x, then y squared. Then with this term, we can see 2 cubed, so 8. And here we have 8y cubed for our last term. And that's it. We have our final answer for our given equation.
X minus 3 raised to 4. When solving this problem in Pascal's triangle, using Pascal's triangle, we need to put 1, 4, 6, 4, 1, because the exponent is 4. Then we're gonna write it down. 1, 4, 6, 6, 4, 1. Just gonna arrange it because I need a lot of space. Six, then 4. Okay, first put x 4 or x raised to 4, x raised to 3, x raised to 2, x raised to 1 or x, then x. There you go. Then I'm gonna put negative 3, next is negative 3 raised to 1, then negative 3 raised to 2, negative 3 raised to 3, and negative 3 raised to 4. Then we're gonna simplify this now. 3 times 1, and then it's x raised to 4. The next is 3 times 1 times 4. Then it's negative 12 x raised to 3. Next is negative 3 times 2, or negative 3 times 3 times 6 is positive 54x squared. Next is negative 3 times 3 times negative 3 times negative 3 times negative 3 times 4 is negative 108x1. Lastly, negative 3 is to 4 times 1, it's 81. And here's the answer.